Okay, today's lesson was about dealing with quadratic inequalities, not because necessarily they're going to be a question unto themselves, but because the concept can be used in excellence questions when we're dealing with discriminants. So we have a quadratic inequality, and we have to basically solve it. And the very first thing that we're going to do is we're going to look at a graph representation of this quadratic. So we graph it, and we can factor it like we normally would. We would just factor that, make it equal 0, and so we get x plus 2, x minus 5, and when we solve that we get x is negative 2 and x is 5. So those are the roots in a normal quadratic equation, but this is an inequality. So if we look at this graphically, we have the graph and we have the roots, negative 2 and 5 for x values, and we have the graph, but when we create the graph in the software of an inequality of the quadratic, it will look like this. And what that means is the shaded area is where the truth lies with regards to this quadratic equation. All in this shaded area of blue is where this quadratic equation ends up being less than 0. All right? So I could plug negative 1 into the equation and it would end up being less than 0. I could plug 0 into the equation and it would end up being less than 0, and so on. So all these x values between negative 2 and 5 make this quadratic statement inequality true. Now the dotted lines in the software mean that actually, in fact, negative 2 and 5 are not included, because remember, if I put negative 2 into this quadratic, it ends up being equal to 0. Or if I put 5 into the quadratic, it ends up being equal to 0. That's not what they're asking. They want it to be less than 0. So it's everything to the right of negative 2 and everything to the left of 5. Now, how do we do this algebraically? Is that once we've done this step where we've actually solved it and got the roots, then we have to represent that shaded area. So how do we do this algebraically without graphing it? Well, we test. And basically what we do is we test a point between negative 2 and 5 to see if it holds true back in the inequality. So between negative 2 and 5, if I make my life really easy, 0 is between negative 2 and 5. So if I test 0 and throw it into the inequality, so I get 0 squared for x minus 3 times 0 minus 10 less than 0. If I work that out, I get negative 10 less than 0, which is true. That is, in fact, true. So that means that all the area in between negative 2 and 5 will hold true for the quadratic inequality. And that means that the actual solution then is written like this. X is going to be at any given time greater than 2, less than 5. So that contains all the possible solutions that x can be to make this quadratic true. That's how this works.